So a prism is a polyhedron with two congruent faces called bases that lie in parallel planes. So we have congruent parallel bases for a prism. And the other faces are called lateral faces. This is the one that I couldn't figure out what it was and had to look up. But now it's like, oh, how did I miss that? For those of you in weightlifting, where are your lats? Over here on the sides, right? Okay, so lateral means like sides. Like lateral movement is side to side. You guys know what I'm talking about? Okay, so that should help you. Okay, the lateral faces are parallelograms formed by connecting the corresponding vertices of the bases. The segments connecting those vertices are called lateral edges. Prisms are classified by the shapes of their bases. Okay, we already knew that. Okay, the sum of the areas of the faces is called the surface area. Okay, so that's like the surface area of the entire thing. If you exclude the congruent bases and you just do the lateral faces, that is the lateral area, which kind of makes sense. Imagine that you cut some edges off of a polyhedron and unfold it. The two-dimensional representation of the faces is called a net. Okay, that's what we did on our first day when we cut out those nets.
Hey man, this is a lot of words.
I know, well that's why I kind of was panicking. But once we had the word lateral, it was really pretty easy.
Who's knocking? Knock back.
We're not doing that. Okay, so are you guys familiar with a can of soup?
Yeah. No.
Okay, so if you like think about the metal part of a can of soup, it's got that, it's a cylinder, right? Hey, it's got the two congruent bases that are metal, and then it's got the lateral surface that's what? Yeah, it's all metal. Okay. So if you include all of the metal pieces, that would give you the entire surface area. Okay, but if you just do like the soup label that only goes around the sides, that would give you like a lateral area. So it's just excluding the tops, the bases, top and bottom. Okay. Except that we were supposed to be talking about prisms and I brought up cylinders. It's fine. It's similar. It's analogous. All right, so we're going to draw a net for this and then find the surface area of a rectangular prism with a height of 2 centimeters, length 5 centimeters, and a width of 6 centimeters. Okay. Oh my gosh, how do we draw this? Okay, so a rectangular prism kind of looks like this. So if you can imagine cutting on these edges and like folding it out to make it flat, like when you break down your Amazon box, that's what we're going to do. Okay, so we've got a length of 5. Whoa, this is not to scale. And then a width of 6, right? And then its height is 2. So it's going to have little flaplets like this. Oops. That are too hot. That wasn't a good too either.
Big?
Just big enough where you can read it. Try to make your 2s as even as possible. Okay, so right now the box does not have a lid. It's got a bottom and it's got sides that we could fold up. But do you see that we need a lid for the box?
See.
Okay, so I'm gonna do another pink big rectangle that is 5 by 6. Does that help everybody's brain? Okay, so now we have to find the surface area. So, how many pink rectangles do we have? Okay, so that's going to be like 2, our surface area equals 2 times our base. Just kidding. Right? Area. Capital B because it's an area. Plus, how many little baby side rectangles do we have?
3.
Almost?
Oh, 4.
How do you draw
Yeah.
normal too?
There's the fourth one. Plus 4. Can we call these lateral faces? LF. So let's just plug in what we know. These are all rectangles, so it's all just length and width. So our surface area will be 2 times the dimensions for my base, which are 5 and 6. Doesn't matter what order they go in. Multiplication is commutative. Plus, oh my gosh, I really just want to write a plus. Plus 4 times the little baby rectangles that are, what? Oh no! They're 2 different sizes. Okay, I messed up. Does anybody see what I did?
Yeah, they're not even.
They're not all the same. Some of the little baby rectangles are 2 by 5 and some of them are 2 by 6. Does everybody see the problem? Okay. Sorry about that, guys.
We gotta erase the whole thing.
No, just that part. Okay. So let's change the color. I've got some green ones, and then I'll leave those other ones blue. So I've got 2 of the green, and then I've got 2 of the blue.
Really 2 times.
Okay, sorry about that. So I made the green ones the 2 by 5. So 2 of the 2 by 5s.
Whoa.
And 2 of the 2 by 6s. Then we could put that whole thing in calculator if we want. 2 times 5 times 6.
104.
What?
104. All of it's 104.
Okay. I'm getting that this part is 60. And then 4 times 5 is 20. And 24. So yeah, I'm getting 104. Now, surface area is 2-dimensional, so it's going to be in square units. So 104 units squared. Oh, centimeters. Well,
Let's never do that again. God, that was hard.
it's only hard because I messed it up. I'm sorry. That was my fault. Okay. This one's going to be better because now we know what not to do. Right?
Yeah.
Okay, we're going to find the surface area of a right rectangular prism with a height of 7, a length of 3 inches, and a width of 4 inches using the formula for a right prism. Oh, that's here. Okay. So this is our I don't want to use the formula. Honestly, guys, the formula, if you just have to memorize it, it's like one more formula. I'd just rather like add up all the rectangles. Is everyone okay with that?
Yeah.
Okay. So Let's make another net. We're going to be better at it this time. What is it, 3 by 4? Let me do that. Okay, so here's my 3, here's my 4, and what's the height?
4. Oh, 7.
7. We're going to be way better at this time. We really do know what not to do.
So many.
Okay, so right now, my box does not have a lid. So I'm going to add a lid. That's another 3 by 4. Oh, you'll be okay. So I've got 2 purple bases. Am I going too fast?
No.
Okay.
It's just a lot.
Surface area is 2 times my base area, capital B, plus well, now we know we can just plug those in. So what is that, 3 by 4? Okay. Plus, there's a pair of 4 by 7 ones, right? That's these. 2 4 by 7 rectangles plus a pair of 3 by 7 rectangles. Put it all in your calculator. What was it? 122, thank you. 122 inches squared. Okay, we're not going to mess with that formula because honestly, I don't think you need it. Like, that thing stressed me out, and I have a degree in math, so we're just going to skip it.
I don't know.
Okay, so here we have a triangular prism. So, if you can imagine, can everybody see what's happening back there? Okay, how many of this triangular face do we have? Do you see that we've got one on the front and one in the back?
Mm-hmm.
Okay, perfect. And then we've got, you see that this side is also 12.8, right?
Sure.
So we've got this face in the front and then this face in the back that match. Does everybody see that?
Yep.
Okay, but the face that it's resting on is different. Okay, cool. All right, so our surface area is going to be 2 times the area of our base, which is 1/2 times our 13. Oops, I wrote 12. Times the height of 11. Okay, so this is our B, our base. Everybody okay with that part? Not yet. Okay, so we're not done yet because we've only done this piece and this piece. Okay, do you see that we have 3 more surfaces to go? Okay. So we then have, like if you think about this as the sides of a tent, we've got this side of the tent and then the back side of the tent. Okay? So each of those is a rectangle whose base is 15 and whose height is 12.8. Okay, and then we have the bottom of the tent, which is this guy. What? What? Yep, plus. We're just adding them all together. So that one is 13 by 15. And there's only one of it. Okay, now you can put that whole thing in your, what is it? Wow. Okay.
Inches?
Square feet. 722 feet squared. That's not so bad.
No.
Now that we got the hang of it. Okay, we can do this. Okay, so I'm going to draw in because this kind of helps my brain count the faces. You see what I'm doing? Because the ones in the back, if I can't see them, it's kind of hard for me to know what's back there.
Right.
Okay. So what's kind of tempting, do you guys see that it's really tempting to say that this is the base? Do you see that that's not the base? It's just what the face it's sitting on. So the bases are the congruent triangle faces. Those are the bases. Everybody happy with that? Okay. So we've got 2 of them. So the area for those triangles is 1/2 times their base and height. So I'm seeing 3 by 5. 3 by 5. Okay, so that's the base of the triangle, or the base area of the triangle. The area of the triangular base is what I'm trying to say. Okay, now we've got to add the back face, the slopey face, and then the face that it's resting on. And those look all 3 different. So this back face, that one looks like it's 3 by 7. Does everybody see how I got the 7?
Yeah.
Okay. Plus 3 by, I'm going to put a 1 in front of it because there's only one of it. Do I need the 1? No, but it helps me count. Okay. 1 3 by 7 plus 1. Let's do the slanted face. That one looks like it's 5 by 8 by 7. 5.8 by 7. You see which one I'm talking about? This one? Okay. 1 times 5.8 times 7. I ran out of room. This is really poor planning. Now the face that it's resting on. That's this one down here.
I thought we were done.
No, because there's the 3 weird faces that don't match.
Oh, yeah.
Okay, so that looks like 5 by 7. Plus 1 by 5 by 7. Kind of ran out of room.
111.6.
What was it?
111.6.
Okay. Surface area equals 111 point. Is it 6 repeating?
It's just like, it just says 1.1.6, nothing else after it.
Okay.
It's yards squared.
Thank you. Thank you. So is it a little bit tedious?
Yeah,
But it's just adding up areas that we already know how to find. So just like take a deep breath, like count how many there are. If you have to make a net, make a net. Don't panic. Just add up the areas that you already know how to find. Okay. Here we go. A cylinder is a solid with congruent circular bases that lie in parallel planes. The height of a cylinder is the perpendicular distance between the bases. The radius of a base is the radius of the cylinder. In a right cylinder, the segment joining the centers of the base is perpendicular to the bases. Okay, did everybody understand that last bit?
Yep.
So if I'm connecting the centers of my circles like this and it's perpendicular, that means I have a right cylinder. If it starts leaning like this, then it's not a right cylinder anymore. Cool?
Yeah.
Okay. The lateral surface area of a cylinder is the area of its curved surface. Okay, this is what I was yammering on about with the can of soup. I probably should have mentioned it here. So this is the label on the soup can, right? And then this is like the entire net that's metal. Okay, perfect. Okay, I'm not going to mess with this formula either. We're just going to like crank it out by adding up it's going to be like, you see that it's going to be two circles in a rectangle for a cylinder? We're just going to add them up. What?
Hard to add up.
All right, well, you see how much I struggled with it at the beginning, so. All right, you are wrapping a stack of 20 DVDs using shrink wrap. Each disc is a cylinder, is cylindrical with a height of 1.2 millimeters and a radius of 60 millimeters. What is the minimum amount of shrink wrap needed to cover the stack of 20 DVDs? All right, so let's draw a picture. Oh. Can you stop? Okay. You kind of make like a squished circle for the top and then draw two parallel lines down. Then kind of draw the front.
Man, why is mine slanted?
And then you do the dash back.
I did it.
Because that's beautiful.
Mine?
Beautiful. It's better than mine. You guys want a job? Yeah. Okay, so the radius of the DVDs is 60 millimeters.
Oh, this has you. R60?
Okay, so it would be really great if we knew the height of our cylinder. What is it?
Whatever 20 times 0.2.
So each of the discs is 1.2, and there's 20 of them. So 20 times 1. Oops, let me do parentheses. 1.2, which is what?
24.
24 millimeters.
Ooh, that's not a cylinder.
Okay, guys, the only thing that we are missing from this is the circumference of our circle, H. Okay, because if we think about what this net would look like, we're going to have a circle up here, circle down here. Ooh, that was a great one. Okay, and then we have this rectangle, right? Okay, do you see that this rectangle has to go around the circle? You see what I'm saying? It's got to go like that. Everybody see it? So the top of that or the length of that rectangle is the circumference of our circle. Everybody happy with that?
Yeah.
Okay. So what is the circumference?
Circumference.
2 pi r.
2 pi r.
So our circumference is 2 times pi times 60, which is
Oh, 376.9 million.
can we just call it 120 pi for now?
Yeah.
Okay. Did you ever think that pi would be like the prettier way to write it?
No.
Okay, so that's C. This length right here is our C. Okay, it's 120 pi. Everybody happy with our rectangle? So the other dimension of our rectangle is the 24 millimeters. Okay. So now we have to do is add up the two circles in the rectangle and we're done.
Okay.
So our surface area equals 2 times our circle base. So that would be pi r squared. Pi r is 60 squared plus 1 times our circumference, which would be 120 pi times 24. Let's round to the nearest hundredth.
31,667.25.
Okay, 30 what?
31667.
31667.
Mm-hmm. Sorry, no. 25.
0.25?
Yeah.
0.25 millimeters squared.
Gosh. Yeah.
Is this our last one?
No, we
No?
have 2 more.
Jeez. All right, maybe we
Oh,
don't
we
have
got 3 more. But we don't have to do the very last one, I think.
Okay, so here we have to find the surface area of a right cylinder with a height of 18 centimeters and a radius of 10 centimeters. So let's draw our picture.
I'm not drawing another cylinder. I'm not doing it.
The right cylinder.
Oh, if only you had
What
your
cylinder
notes.
isn't right?
One that looks like this. Hey, not right.
It's slanted.
Okay.
Right. Okay. That's an alternate design for the can of soup. Okay, so what we need to find then, what they didn't give us is our circumference, which is going to be the width or length of our rectangle, right?
Mm-hmm.
So our circumference is 2 pi r, right?
Yeah.
So 2 pi r, I'm getting 20 pi.
This is the only thing I look wrong. I'm not an artiste.
Okay, so our surface area, oh, good golly, my brain is not off the 3-day weekend. We have two circular bases. So that would be pi times our radius of 10 squared, but there's two of them, plus one rectangle, which would be 18 by 20 pi. Then we'll round to the nearest hundredth.
Not right now. You might be over in 2 seconds. 1759.
Okay, I heard
1759.
1759.29. Thank you.
That's
Centimeters squared.
Yeah.
Are we wearing our crowns?
Hey. Oh, here.
If Miss Bond does not stop posting a sign.
Hey. All right, so we've got to find the height of a cylinder. Hey, shh. With a radius of 2.5 meters and a surface area of 157.08 square meters. So this time we're not finding the area, we're using the area and a radius to find the height. So let's think about what we know.
Well, the radius is 2.5.
Okay, so we don't know the height.
You're being a bone.
I heard it. Ow. Okay, and we know that the radius is 2.5. And we know that the total surface area is 157.08. Okay, so let's think about like how we would find all of the stuff that would add up to that. So if I think about my net.
No, Matt.
Yes, net.
Come on, Brad.
Okay. I know that this is the height right there. Okay, I know that the circumference has to be 2 times pi times my radius, 2.5 squared. What do you get for that? Just what's 2.5 squared times 2, and we'll leave it in terms of pi for now.
What is that noise? 39.27.
39.2. Okay, 7 pi.
I did the 2.5.
Oh, no. I want the pi still in it. What's 2.5 squared times 2? Okay, that's what I got too. All right, so 12.5 pi. Okay, so that's this bit. Okay. And then we've got our two circles. So this is going to be equal to our 2 times our pi times our radius squared, which would be 2.5 squared, plus 12.5 pi times our height, right? Pi. What? We don't know. That's what we're trying to find. Okay, so do you see that the only thing we don't know in here throughout the whole thing is the h? Okay, so we can set it up exactly the way we set up the other ones, but we just leave the h in for the height because we don't know it. Okay, we know what the surface area is, so we don't need this. We just have to solve this for h. So if I simplify this chunk right here, I'll get a number. So what do I get when I do 2 pi times 2.5 squared?
Sorry, what did you say?
2 pi times 2.5 squared. Oh, I should not have squared this. I messed up. I messed up our circumference. It's just 2 pi r. So 2.5, this should just be 5 pi. I'm sorry, guys. I had a brain fart. My lunch made me a little bit dumb. Okay, let's fix that.
No.
That would be 5 pi. Okay, where else did I write that wrong? In here. Sorry, guys. Brain fart.
I'm gonna give you the 12.5.
No, but you did what I told you. I told you to square it. And I kind of combined the area and the circumference formula into a hybrid made up formula that was not real.
For the 2 pi times 2.5 squared is 39.27.
Okay, 39.27. Okay, so that's what we're subtracting away from both sides. Okay, so what is 157.8 minus 39.27? 118.53 equals 5 pi times our h. Right? Because these canceled. Okay, so how do we undo multiplying by 5 pi? Yeah, divide by 5 pi. Divide by 5 pi.
Um,
74.47.
it's 117.81.
What?
Oh, what?
Doesn't even make sense how you got 3 in the last place.
I don't know. We
Just
probably
look at it real quick.
Okay.
0.08 minus.
I don't know how to explain this to you, but it's really disorienting when your face is like that close. Like, so I need all the help I can get. So I believe you, but let's check it. 157.08 minus 39.27. Okay, so it's 117.81, and we're going to divide that by 5 pi. I'm getting 74.02.
Yeah.
You're fine. If they don't want to erase, they should be doing it too and helping us out. Okay, so if our area was square meters, our height is just going to be regular meters.
We got one more.
I think the next one might be like the one that we just did, where we have to solve for a height or something.
Find the radius of a right cylinder with a height of 5 feet and surface area of 200 meters.
Okay, do you want to solve for the radius, or are we good?
We're good.
Okay, we're good.
Wait,